we will be identifying situations in which work is done, meaning there's work. Work is not done, meaning no work. An easy way to recall some of the concept here. Work is done when there's force and displacement, meaning the object is moving from one position to another. And then no work means no motion. Even there is a force, but then again, the object is not moving, no work. Okay, so let's try to find out. We have first picture, the very famous drawing about a falling apple. So the apple falls to the ground, and let's try to identify the kind of force acting on the object in our system. So our object here is the apple. Okay, and what force is responsible for that falling mechanism? Of course, we have gravity. So the force involved here is the gravitational force, or we can just write it as gravity. And let's try to look at the direction of the force. And then we have direction of displacement. It's true that there is displacement in this case because before falling, the apple is in this position. It's going to be our initial displacement. And now the apple is in this particular displacement. That's going to be the final displacement. So there's a change in displacement. Okay. And look at the direction of our displacement here. It's going down. The apple is going down. So a displacement also is going down. We will put it there. The apple is going down. So the force of gravity, look at the force of gravity here. I will make it a bit bolder. It's going down. In that case, we have a force and the object is being displaced. Check force and then displacement check. Yeah. What will be our remarks in terms of work? Work, uh, work is done, or work is done. Okay. Actually, it's a positive work. Okay. It's a positive work. We will be knowing more about positive work uh, in this video. So when we say positive work, energy is being increased. Energy is increased. As you look at it, the apple falls down, and when it falls, it speeds up. Okay, so it gains more energy. What particular energy? It's the kinetic energy. So energy is increased when you will have positive work. Positive here is not direction. Remember, work is scalar. So no direction, just value. So the plus sign here, it's not about going upward or rightward. The positive work means energy is increased, or there is an additional energy in the system. We can say that gravity does positive work to the apple. Look at their direction, uh, going down, going down. Same direction. If that's the case, if we have same directions of force and displacement, the work is positive. So now we will have another sample here. What if we have a system here A ball is thrown upward. Okay, so now the ball is thrown upward by a certain force. Since the force is upward, let's say that's an applied force, or we can have it like FAPP, meaning applied force. A force being applied to the ball. And look at the direction of the ball, it goes up as well, following the direction of the force. Okay? Now, is there work there? You apply, you apply, you applied force to the ball, and then the ball is being displaced. We have the initial displacement, and at some point the ball is here. This will gonna be final displacement, and look at the direction of displacement. It's going up as well. So force applied to the ball, and then the ball moves upward. The force involved there, it's the applied force. Okay, I will erase first this stuff here. Applied force acted on a ball, and then the ball moves. Let's look at the direction of the force. Here, the direction of the force is upward. And what about the direction of the displacement? Look at the direction of the displacement. The ball is going upward as well. So we can say that the displacement is going up along with the force. If that's the case, applied force does positive work to the ball. Why? Because direction of the force, applied force is upward, and then the motion of the object is same with the direction of the force. So we have positive work here, and then energy is increased. Okay, if you applied force to the ball will increase its energy, or increase its so-called kinetic energy. Positive work means additional energy because of the force applied. Okay, so what if we have another example here? Okay, what if we will be focus on the ball on air, meaning after someone applied the force to the ball, it increased its energy, it increased its speed for some moment, and then afterwards have a ball on air upward. It will not gonna last long, right? If we throw the ball using an applied force, the ball will gain kinetic energy or increase its kinetic energy. The force is upward, and then the ball moves upward, so it does positive work. But what if after minutes, okay, the direction of the force, it's going upward, but we have another force pulling it downward. That's the force of gravity. Okay, so the force of gravity is our responsible force that acts now on the ball on air. So it drags the ball downward. The direction of the force of gravity is downward, but look at the direction of the object at it is being thrown up. It's going up. The direction is upward as the ball is still displaced or has displacement. This is the initial, and this is going to be the final. So there's a displacement going upward, And if you look at the direction now, force due to gravity is downward, and then displacement as the ball goes up, it's upward, different directions. So if it's different, is there work done? Is gravity does work to the ball? Of course, yes. There's work. There's work done in this scenario. And that work, we call it a negative work. Okay, it makes sense. Just look at the directions of force and displacement. If it will have different direction, therefore the work is negative. Negative is not direction here. It means decrease in energy. If we look at the moving object, so kinetic energy will be decreasing. So it makes sense because when we throw the ball up, it will slow down because of this force of gravity that pulls the ball down as it goes up, opposite in direction, and it decrease energy. That's why the ball slows down when the ball goes up, and it stop as it height maximum height. And then once the ball will go down, it will gonna increase or speed up due to gravity. Just like the ball falling down, it speeds up. But when the ball, just like apple going down, it speeds up. So as the ball goes down, it also speeds up. Okay, the ball loses its kinetic energy because there's a gravity that does work to the ball. Okay, they're in opposite direction. The ball's displacement is upward. Sorry, again, the ball's displacement is going upward, but then again, the gravity pulls it downward, so it decrease the energy or decrease the kinetic energy. That's why it slows down once it goes up, and then speeds up once it goes down because the gravity is helping the object to go down. Okay, I hope it makes sense. Negative work. Negative is not direction. Negative means decrease in energy. And since we're dealing with moving objects, so kinetic energy will be decreased because of the gravity that does work to the ball. It's just that their displacement's direction is opposite to the direction of the force, not the same. So it's a negative work. Okay. Another example of a negative work, so that you will be able to comprehend it more. Let's say we have a rough road, and then we have a car. Oh, not a car, but still a ball. Now, the ball is going to this direction. Of course, there's a force, an applied force that results to the motion of this ball going to this direction. We have initial displacement and we have final displacement. There is displacement, right? So the applied force does positive work to the ball. If you look at it, the applied force, that's our force this time. The applied force, that's the reason why the object moves. So the applied force is our force here applied force is going to the right, and then the displacement of the ball is going to the right. So if you look at the direction of the force and the object's displacement is the same, work is done, and then it's a positive work, meaning energy is increasing. And since it's moving, KE increases. Okay, so applied force does positive work on ball. But let's look at another system. We will focus on the this rough road. Rough road opposes the motion of the ball. So the ball is going to this direction, to the right. That's the displacement of the ball, but we have an opposing force. We call it friction force. It opposes the motion. Okay, so we have friction force here, and the direction of the friction force is going to the left, while is the ball's displacement is going to the right. So opposite or not the same. So work is still done. Work is there. Work is done, but the work is negative work. And what does it mean? Energy is decreasing. KE in a moving ball on a rough road, it will slow down. So KE is decreasing. So friction does negative work to the ball. So I hope you will know how to identify positive work and negative work. Very clear that positive work when both force and displacement of the object is same or are the same, and work is negative when directions of force and displacement are opposite, just like this. Another example, we have this is a wall, and then we have a person trying to push the wall, so the direction of the force is to the right, but then the wall didn't move or no motion. So if no motion, let's say we have okay, I will erase first this one. What if we have an applied force, because the person is applying force to the wall, and then the direction of that force is going to the right, but then no motion or no displacement. Is there work or no work? This is an example of no work. The North Star, if the situation has no work, it's when there will be no motion of the object. So no work is done. I hope you like the video or you learned something. Thank you so much for watching, and I hope you will give it a thumbs up and subscribe to this channel if you're new. See you in my next video.